Hello, welcome back to BLENDERSUSHI Live Coding. In this episode, I'm going to try to kind of make a color texture visualization inside Sverchok to visualize the displacement and the noise. Yeah, I'll just get started. I have another blender doing render, so it might slow down a little bit, but should be okay. File, save as. This is Sverchok displays viewer. I have not tested this, so it might not work, but let's have a look. Fractal. Let's try this node, and I'm going to create a, let's see, just use a grid for now, plain. And we're gonna have bmesh viewer. Plug that in, 10 by 10. This is a 10 by 10 points, so 100 points we have. And let's see, 100 points. We can also use vector noise mk2. With this guy, we actually have like a vector output, which is nice. Okay, so we're gonna use cycles, and let's create a material for this guy. And for the cycles material, we need to use attribute. This one, emission. So there's a few things to set up. So that's the material, and we need to assign it to this guy and merge vertices, edges. Okay, so we need to use vertex color new, and let's get our object here. Index color should come from this guy. Let's try with vector noise as first of all. Vector noise, standard Berlin, and if we check it using vertex paint, okay, we actually have some noise color being generated. That's because of this standard Berlin. So this is the visualization thing that I was talking about, being able to see the texture and kind of guess how this is gonna displace our mesh. Standard Berlin, Blender, Voronoi. We can have more points, 50 by 50. This is 2500. 40 by 40. Maybe actually a scalar, this vector. For the same purpose, we can also do it like this. Okay, this is the fractal noise. Multifractal, actually just use fractal and then play with this value. So this is like a, maybe it's like a Musgrave texture, or this is more like a, oh, it's also dependent on this guy. Cell noise, Blender, standard Berlin. It just have these extra options. So this is almost like the Blender own procedural textures, which is normally you have cloud, Musgrave, wood, but we kind of building it inside Sverchok. Okay, now we can visualize it. Maybe we can try scatter some objects or doing displacement. Maybe let's scatter some objects first. So based on, remember it's gonna be based on points, not the face itself. So we're gonna instance some objects. real quick. Let's do it like this. Oh, apparently we cannot have the color and the 3D at the same time. It's okay. Let's go to let's do some instancing. Let's just use a viewer draw, and we're gonna use the position vertices from this guy. Matrix in, location, matrix, and now we have how many? 1,600 transformation matrix, and we can use that for our instance objects. Let's just use box for simplicity. Box is very basic, but it's perfect for what we are doing. For the size, we can use just this guy, vector in, this guy. 1, 2, 3 goes into the matrix, or actually I forgot, we can just plug this guy in there. Now we have the noise influencing our objects, and of course they are not normalized at the moment. Normalized meaning they're not like, the value is not between 0 and 1, and it's totally up to you whether you want to normalize it or not. If I'm not wrong, if I'm just using like cycles for this mesh, SV call, okay, SV call, and so this guy, if I render it out, it's gonna be displaying the noise while this guy is showing the result. Okay, this is almost like a Blender on preview. So at the moment, looks like wherever is the black, we get like the small box. Wherever is white, we have like a big, really big box. We can try to normalize this. So go back to Sverchok here, and this is like visualizing noise. Save again. With cycles, if you make this like a really small, it's actually super fast. So for that, I think I can just use this 3D view, and these guys can be rendering. Okay, that's nice. And let's remap our value here from the fractal. Remember, this is all live. If I change the value, everything should update. This cycle texture is gonna update, and then this guy is gonna update. Everything's connected. Okay, map. Let's check the value real quick first using viewer text. So plug this guy in there, and then view. Look text editor, and then have a look. Apparently the value is like between minus, the high value is actually really high. This is quite interesting. Actually, we don't actually always need to normalize it, although I have a feeling that we need to normalize it anyway. So we need to know the minimum value and the maximum value. Sometimes the max goes up to 3 here, so I like this vector fractal for that. It's quite unpredictable. If I normalize it, we get a kind of more controllable value, but we kind of lost the unpredictability. So this is vector color. It's the big mesh. There's a color value going there. That's the new preview. Let's change this minimum maximum. So this is a little bit, I guess it's more like a contrasty and more normalized. It becomes like a cloud. And so, okay, let's make this like that. Plug this into the box. And wait a few seconds and we have this result. See, this is looking more like a cloud now. You can always push the value, so not too much. This one maybe -1. You can kind of clamp the value. Okay, this is actually, there's a clamp already. Maybe I turn off the clamp, so yeah, it's more natural like this. So we have 1,600 boxes, and each of the scale being controlled by this fractal inside Sverchok. This guy, multi-fractal or fractal. Let's try changing this and just to test the different result. Fractal, Voronoi. This is more like Voronoi. This value, maybe change to 3. Cell noise usually quite different, more random. And but don't forget that we also have this vector noise, so kind of wondering how this guy looks like. Noise scalar. Plug that into the box. This is Voronoi. Let's try standard Perlin. Okay, it's pretty predictable. Maybe the texture is too small at the moment. So with vector noise, remember we need to use vector math here just to scale the value. Change this to multiple scalar. Let's try big value. Smaller value. Okay, now it's more obvious. Looks like a cloud. We can change the seed value. And here, I think we also need like a map range to be able to control the scaling. Plug that in there. -1 and 1. Maybe this can be 2. This one 1. The value must be super small here, maybe between 0 and 1. Let's check it out using viewer text. Plug that guy in and then view 0.4, 0.5. See, this guy looks like it's already between 0 and 1. Very interesting. So it's already normalized. The difference between Sverchok and the displace modifier is, of course, because when you're doing this kind of instancing, you can actually deform each and every point of this guy. Furthermore, so here we have like 1600 objects with a 1600 transform. If I actually made it like if I join them, and let me think how to do it. We can mass join. So first we need to apply the matrix, I think. It's the box 600. Probably gonna cut this. Plug that guy. This guy. And here we still have 1600 objects. We want to join them. So now if I actually cut this, plug that in and plug that in, should be like a single object now. So we have a single object, and we can randomize further this guy. Vector noise. And here we can use a vector math. This should be add, and then just add these points and the noise together, and we should get a random looking boxes. So this is like almost like 2 displacement and then instancing and then displacement again on top of the instancing. Quite complex indeed, but everything in one go. and everything is still kind of procedural. Let me reduce the strength of the noise first, using this multiply by scalar, and plug into our noise. Plug into that guy as well, just in case we want to make it stronger or less. It's totally up to you. See, it's pushing the mesh. It's not actually, it's not using the normal, it's just all these points going through the noise, and then it's causing this to happen. Now with the intermediate objects, which is the plane, we can just hide it, and we don't need to render it. And we have this. So it's quite unusual, but it's still I think this is pretty cool. Something you can do inside Blender using Sverchok, and it's pretty unusual. Try doing this in other 3D package. It's not that easy. Okay, see, so this is a baked version. So again, there's a lot here, a lot of things going on. We have this noise. We can change it to another noise, or noise, cell, maybe cell, more random. Actually, this looks like city. Turn off matcap. See, I can always go back to the original plane. And let's summarize what's going on. Let me hide this. We don't need to render it out. I quite like the Voronoi. Just now, it's like a Voronoi 2, Voronoi 4. Yeah, quite like this one. So let me summarize what's going on. We have this plane made out of 40 by 40 points, and the points kind of generating these template points. This is for the preview of the texture itself, procedural texture that's being generated inside Sverchok. Even though we don't need to see it, but the texture is good indicator for what's gonna looks like here before we displace and then randomize, generating instances, and then also this displacing the instances. So there's a lot of things going on here, and we have 1600 of these guys, and you can use, instead of the box, you can use other mesh, but it could be heavy. But remember that this is all procedural. Anything's changing here will reflect here. So if I make it as 10,000, so it's gonna generate 10,000 different noise to instance 10,000 objects, and then also to displace 10,000 times the cube. So 10,000, and the cube is made of 8 points, so maybe we have 80,000 points now being generated on the fly, and then they're all kind of real time. Let's just make it smaller. Sometimes big number can be a hassle. Yeah, so keep that in mind. It's even though they look cool, but they're such a mess if you don't know how to control them. That's why it's nice being able to do this. Remember that you don't actually need the plane. You can change this to anything, including random points or any kind of voxel structure, or maybe like Suzanne face. You just need to plug into this guy. We need, of course, a way to kind of organize this better. This is the box. I can just change the box into something else and it will work. Now that's adjusting the strength of the noise. You can randomize the seed, get different displacement, and also I think this fractal we can use with the box or matrix. This location from the grid goes in there. That's controlling the noise here. So anyway, this is for the preview. If I turn the preview once again, you can go back to 3D view and then have a look. There you go, the preview. Again, 60 by 60, 3600 objects. Now this guy is gonna update itself, and then this instance is gonna update itself. Yeah, so there you go. Much more high res. Maybe make this 100. 6,000 instances and then 6,000 points to generate the texture. Just keep it under 10,000 and it should be alright. If you have like a 4 gig of memory, I'm using my old MacBook Pro and still pretty fast. So I quite like this. Pretty happy with the result. Yeah, okay, that's pretty much it for this live noding. If you have any question, suggestion, just let me know. We haven't touched on the vertex normal. Maybe I will do that next. Vertex normal and procedurally generated texture using Sverchok. Remember that the texture, the noise that we are using currently came from fractal and vector noise. You can always make your own procedural texture in here. Any kind of texture you can think of, just use a script node, one of these, and have your own texture. It's almost like OSL, the open shading language, but basically what you need to do is to generate some kind of number patterns that you can use for XYZ or RGB, and then you can pipe it down as a procedural texture inside Sverchok. So it's really powerful. Just give it a try.